Let's look at some examples of graphing conic sections that put everything together. So let's sketch a graph of this conic section, r equals 2 over 1 minus 1/2 cosine theta. So since we have a cosine here, we know that our conic section will be oriented horizontally. Okay, and comparing the general equation for a conic section, E times D over 1 plus or minus E times cosine theta or sine theta, but for this one it's cosine. Notice that the E, the eccentricity of our conic section, shows up right here next to cosine. So for our conic section, we know it's horizontal. We know that its eccentricity is 1/2. Okay, now comparing numerators in these things, 2 has to be E times D. So 2 is E times D, but we know E is 1/2, and so D has to be 4. And remember, D is the distance from the origin, which is also the focus, to our directrix. So D is 4. And because of this minus sign in the denominator, the directrix is to the left of the origin. One final thing to notice is that our eccentricity is less than 1, and so that means we have an ellipse. Okay, so now we can sketch this. So here's our one focus of the ellipse, and our directrix is 1, 2, 3, 4 units to the left of the focus. The eccentricity is 1/2, so that means the distance to the focus is 1/2 of the distance to the directrix. We could do the algebra to figure out exactly where the point in between should be, but it looks like it's about here anyway. And since we have an ellipse, the ellipse has to go to the right. The ellipse can't go to the left because then points on the ellipse would be closer to the directrix than the focus, but that's backwards. So our ellipse is going to be something like this. And that's a good enough of a sketch for now. I think the important features of this graph to be somewhat accurate about is where is the directrix relative to the focus, how is your conic section oriented, that is horizontally or vertically, and what kind of conic section is it? Is it an ellipse, a parabola, or a hyperbola? All right, let's look at another example. So let's sketch the graph of r equals 2 over 1 plus sine theta. So comparing this to sort of the related version of our conic section equation, that would be E times D over 1 plus E sine theta. So because of the sign here, we know that our conic section is going to be oriented vertically. Okay, comparing denominators here, since these ones match, that means that the coefficient on sine is going to be our eccentricity, and so eccentricity is 1. And when eccentricity is 1, that's when you have a parabola. Okay, now we can compare numerators. So 2 has to be equal to E times D, but the eccentricity is 1. And so our D value, that is the distance from the focus to the directrix, is 2. Okay, so now we can sketch our parabola. So the focus is at the origin. Since because of the plus right here, the directrix is above the focus and not below it. So it's in the positive y direction and not the negative y direction. So up here, so 1, 2 units in the positive y direction. And we need a parabola. So because it's a parabola, the distance to the focus and the directrix has to be equal, and that means the vertex of our focus is halfway between right here, and so our parabola is going to go downwards like this. Okay. Again, the important features to depict here are where is the directrix relative to the focus, and what kind of conic section do we have? Parabola, hyperbola, or ellipse? And the orientation, vertical or horizontal. All right. One more example. Let's sketch the graph of this conic section. R equals 12 over 3 plus 6 cosine theta. This does not really look like the general form of a conic section equation that we've been working with. So because of the plus in the middle and the cosine in the denominator, we should probably compare this to e times d over 1 plus e cosine theta. And the thing you might notice right off the bat is that the equation we have has a 3 in the denominator, and the equation that we're used to using has a 1. So what we should do, I guess, is somehow force this 3 to be a 1. And the way to do that is just to factor a 3 out of the denominator. So let's rewrite this equation. It's 12 over, so we're going to factor a 3 out of the denominator. So 3 times 1 plus 2 cosine theta. Okay. In this particular example, it looks like we can actually just go ahead and simplify this so that the 3 is gone completely. We get 4 over 1 plus 2 cosine theta. Okay, and since our eccentricity shows up in our denominator, it's 2, it would be nice to split up the numerator so that the eccentricity shows up. So 4 is 2 times 2 over 1 plus 2 cosine theta. Now comparing this to our general form for this kind of conic section, ED over 1 plus 2 cosine theta. Now we have our 1's matching. So because of the cosine, we know that our conic section is going to be oriented horizontally. Because of the 2 right here, we know that the eccentricity is 2. Because of the plus, we know that our directrix is going to be to the right of the focus. And in the numerator here, right, our eccentricity is 2, and so that means this other factor in the numerator should be d, so d is also 2. All right, so now we can sketch our conic section. We'll have a focus. Our directrix is 2 units to the right. And let's see, to get a point in between, the distance to the focus should be twice the distance to the directrix. So it looks like about here. And since this eccentricity is greater than 1, that means this is a hyperbola. Okay, so there's another point on the hyperbola somewhere out here, and we get something like this. All right. So again, the important aspects to depict are the orientation. This conic section is horizontal. What kind of conic section? This one's a hyperbola. Where the directrix is compared to the focus, and it's to the right of the focus, and the distance between the directrix and the focus.